Hi everyone and welcome back to the channel. Today we are tackling an essential home improvement project, replacing a shower mixing valve. If you're dealing with temperature issues or leaks, stick around and I'll guide you through the steps to fix it yourself and save some money. Let's get started. Make sure that the water is turned off at the source and all the lines are drained by opening up all the faucets in the house. The first step is to expose the plumbing by removing the sheetrock directly behind the mixing valve. Try to cut the sheetrock on the studs by using a stud finder or by locating the screws. Move the pipe support so you can get a 1/2-inch tubing cutter around the copper pipes. Residential supply lines will always typically be 1/2 inch in size. Spin the cutter in a clockwise position. It will automatically tighten as it gradually cuts the pipe. Don't squeeze and let the tool do the work, as copper is a soft metal and you don't want to risk denting the pipe. Cut the hot and cold supply lines in the same fashion. Some tubing cutters don't tighten automatically, but I really recommend this one as it'll save you a lot of headache working in tight spaces. It's a good idea to keep a bucket nearby to catch any water trapped inside the lines. My supply lines come from the ceiling, as this bathroom is located in the basement of the house. A lot of the time the plumbing will come from the floor, so make sure you verify the plumbing location and cut the sheetrock appropriately. Cutting the pipes can be a tedious process. Just be patient, don't squeeze the cutter, and persist until the cutting wheel is completely through the pipe. Once all the plumbing is disconnected, remove the old lines along with the broken mixing valve. Make sure to dump out any water that might be trapped in there and store the copper for your scrap pile. Here is the new mixing valve we're going to install. This one is made by Moen. I've already threaded 3 new brass 1/2-inch male crimp to 1/2-inch female adapters for the supply lines on the sides and on the top for the riser pipe to the shower head. Make sure to apply Teflon tape clockwise on the mixing valve threads before screwing on the adapters. Wipe off any debris from the pipes before using a fine 120 grit sandpaper on the portion of the pipe we will install the fittings. Using sandpaper on copper pipes helps to clean and smooth the surface, removing any oxidation, dirt, or corrosion. This ensures a better, more secure connection when soldering or fitting the pipes, leading to a leak-free and durable plumbing system. Repeat the process on both of the supply lines. You'll want to make sure that you are sanding at least the final 2 inches of the pipe. It helps to use a flossing-like motion, utilizing leverage to ensure you are sanding tough-to-reach places like the backside of the pipe. You can run your fingers along the sanded area to ensure it's smooth and free from rough spots or burrs. We are going to be installing these 1/2-inch PEX-B to 1/2-inch female sweat adapters on the copper pipes to allow us to transition from the copper to PEX-B. Next, you will want to scuff the inside of the fittings using a 1/2-inch wire brush. This removes any debris and creates more contact area for the solder, resulting in a tighter and more secure connection. I'm just adding a temporary support block to stand out the pipe a little bit for better access. Next, we're going to apply a flux paste to the sanded parts of the pipes, as well as inside of the fittings. Aside from cleaning, flux paste helps draw the solder into the joint when heated up. As it melts, it flows into the joint, pulling the solder in with it, ensuring the whole surface is bonded. Without this, the solder would just drip off the pipe as it's heated. Now comes probably the most intimidating part of the project, sweating the pipes. I am using a Bernzomatic propane torch to heat the fitting. Make sure the flame is about 1 inch or 2 away and move slightly back and forth to heat the fitting evenly. Have your solder uncoiled a few inches so you have some slack to work with. While maintaining heat on the fitting, tap the solder around the joint between the fitting and the pipe to test if it's ready. When the solder begins to melt into the joint, it is ready. This can take anywhere from 20 seconds to a minute, depending on the pipe size. In our case, it took about 25 seconds. Move the solder all the way around the joint. The flux will help draw the solder into the joint for full coverage. Apply additional flux to the soldered fitting as shown. Repeat this process for both the supply lines. I put some scrap sheetrock behind the pipe to protect from the flames. Some metal or some flame retardant fabric can be used instead. A helpful tip is to bend the solder around the pipe to give it a hook shape. This will help you reach the back side of the pipe. So again, we're applying flux paste to the copper pipe and to the inside of the adapter. Make sure that's fully coated. Quick shout out to my beautiful wife Liz for helping me hold that adapter in place. Now applying the torch again to the adapter. This is just on the adapter itself, the brass adapter, and not the copper pipe. You actually want to heat the adapter so it draws the flux into the adapter. Notice how the hook shape on the solder helps me reach behind that pipe. Next we'll be installing our 1/2 inch PEX-B with these 1/2 inch PEX clamps by SharkBite. You want the clamp to be straight on the PEX, and only about 1/8 of an inch to 1/4 of an inch from the end. You will need a special SharkBite PEX clamp tool to clamp it tight. Once the tool is completely engaged, the clamp is set. Line up the mixing valve in the center of the original hole. Mark the PEX and cut it with the PEX cutter so it fits tight over the fitting. I'm just checking for burrs by scraping the PEX with the backside of my utility knife. I found that with the PEX cutters, it was a pretty smooth cut and there were never any burrs, so this step is probably not necessary. Align the mixing valve in the center of the hole. Line up the clamp facing forward, leaving about 1/8 to 1/4 of an inch gap from the end, and crimp with the PEX tool. Just adding the support back to the riser pipe to keep everything in line. Next, I'm installing the PEX supply line. I pre-cut the PEX, leaving it a little long so I could maneuver it easier in the wall. The clamp is angled slightly away from the stud to ensure I can get the PEX tool fully around the crimp. Next, I'm installing the PEX 90-degree elbow. Mark and cut the PEX supply line so that the horizontal run will be level going into the mixing valve once the elbow is installed. It doesn't have to be perfect, but get it as close as possible to level. Measure, mark, and cut the horizontal run before crimping anything. I like to dry fit everything before making the final crimps to ensure everything fits together nicely. I'm going to go ahead and repeat the process on the other supply line. I'm going to go ahead and crimp the vertical run so that it stays nice and secure. Mark and measure the horizontals and dry fit and make sure everything fits together nicely. Make sure your mixing valve remains centered in that hole. You want to make sure this is lined up in the original location so that the faceplate goes on nicely. Once you confirm the mixing valve is centered in the hole, all the plumbing is tight and all the fittings are straight and level, you can proceed with crimping all the clamps down. To ensure the clamp is properly installed over the fitting, make sure that all your cuts are square and cleaned of any debris or burrs, and make sure that that clamp is aligned nice and straight over the PEX. And remember, make sure the clamp is about 1/4 to 1/8 of an inch away from the end. Now that I have everything lined up and in place, I'm good to mark and cut the other supply line to the appropriate length. Remember to fully engage the PEX clamp tool so that the clamp is 100% tight around the fitting. Now, they also make push-on SharkBite fittings that will work on PEX and copper. However, since this wall is getting buried behind sheetrock, I want to ensure that these fittings stay leak-free, and I think this clamp system is a little more tried and true. But certainly, if you didn't want to sweat anything, those are a viable option. You can see here that I'm applying pressure to the bottom of the fitting just to make sure that everything is super tight when I crimp this final piece into place. And just one final test to make sure that mixing valve is centered in the hole. You'll now have to consult your specific mixing valve directions to make sure the plaster guard is aligned properly. This orientation will depend on what type of shower you have, like tile or vinyl surround, This shower is a vinyl surround, so the plaster guard basically sets the depth of the valve while also aligning the screw holes for the faceplate, also known as the escutcheon. To finish this project off, follow the instruction manual to complete the installation of the key stop, adjustable temperature limit stop, level handle adapter, and the handle itself. Make sure to turn the water back on and run the shower to look for any leaks before closing the wall back up. So that is how you install a shower mixing valve with sweat adapters using PEX-B crimps. Hope you enjoyed this video and learned some new things along the way. Good luck with your project, and please consider liking and subscribing for more step-by-step instructional videos. Thanks for watching!